Welcome everybody. Let's talk about the calorimetry experiment itself. So in lab the other day, you carried out a calorimetry experiment where you determined the specific heat capacity of a piece of metal. Well, in order to do that experiment, you needed a calorimeter. And a calorimeter is simply a device that we use to measure heat transfer. And the one we used is a coffee cup calorimeter, which consists of two nested styrofoam cups full of water and a thermometer to measure temperature. The styrofoam cups ensured that all the heat that was lost by the metal went into the water and didn't go into the air. That way we could measure the amount of heat that was transferred from the metal to the water. The thermometer, of course, is how we're going to figure out what those temperature changes are. So this is the calorimeter, cups with water and a thermometer. Let's talk about the experiment that you did. So at its simplest, a calorimetry experiment consists of the following steps. You're going to measure the mass of the water in the calorimeter and the initial temperature of that water. You're going to figure the mass and the initial temperature of whatever material it is you're adding. And then you're going to take that other material, drop it into the calorimeter, wait for the temperature to stop changing, and measure the new temperature. What this is going to allow you to do is it's going to allow you to determine the amount of heat change of the water using the equation Q equals mc delta T. And we've seen this equation before. M is your mass, which is why we had to measure it. The specific heat for water we know is 4.18 joules per gram degree Celsius, and then delta T is the change in temperature. Then, once you know that amount of heat gained by the water, you know the opposite was what was lost by the metal, or whatever other material it is. So here I've used Q system to represent the material of interest because that's what we're studying. And then once you know what that value for Q for the system is, you can use the equation Q equals mc delta T to do things like solving for the specific heat capacity of this other material, just like you did in lab. And so as a result, we have a very simple experiment. We're just putting something in water, and yet we're able to measure the amount of heat change of that material, as well as information about that material like specific heat capacity or perhaps mass if that's what we didn't know. For a really simple experiment, we can actually get a lot of really useful information for things that are hard to measure directly, and that's the beauty of calorimetry.